let's take a look at some new stuff here quick. What we're going to look at today is what happens if okay, so let's say we have this 3 inches by 7 inches. What's its area? 21 square inches, right? Let's say I blow that up. Enlarge it. Now it's 9 inches here. First of all, what's this going to be here? 21. Because our ratio of lengths was 3 to 9, or reduced to 1 to 3. So you'd use that 1 to 3 to turn the 7 into a 21. What is the area of this one? 189 inches squared. Is that ratio of areas equal to the ratio of lengths? 21 over 189, if I reduce that, that's a 1 to 9 ratio. They're not the same, are they? Let's take a look at another example. Let's take a square that's 2 inches on the side. And I'm going to blow it up to be 8 inches on the side. What's my ratio of lengths? Yeah, 2 to 8, or 1 that reduces to 1 to 4. What's my area here? 4 square inches. And my area here? 64 square inches. My ratio of areas is 4 to 64, or 1 to 16. They're not the same. Do we see a relationship, though, between the ratio of lengths and the ratio of areas? What is it? Yeah, if I square this, 1 squared is 1, 3 squared is 9. I square this. 1 squared is 1, 4 squared is 16. The ratio of areas is the square of the ratio of lengths. So that becomes useful if I have irregular shapes. Question, Nick? Right, so you
the ratio of lengths is
just the two corresponding sides.
Irregular shapes as in not straight lines?
Yeah. They're confused, Nick.
the ratio of, what'd you say?
The ratio of areas is the ratio of lengths squared.
You see that? You square the top and bottom on that measure.
Let's do this. Let's take
Look on it.
6-inch side here, and it's got this really weird looking shape. And I'm going to cheat, of course, because I can. Let's say I'm going to blow this up now to where it's 10 inches. I'm going to say the area of this is 300 square inches. What's the area of this one? Well, what's my ratio of lengths? 6 to 10, which reduces to a 3 to 5. And you don't have to reduce it, but it makes life a lot easier if you do, because when we go to square it, you get some really ugly numbers if you don't reduce it. Now to get the ratio of areas, we take that ratio and we square it. So it's each number squared. 3 squared is 9. 5 squared is 25. So my ratio of areas will be 9 to 25. Where's the 300 going to go? That's from the 6, which is the top number. So it's 300 on top. We cross multiply and divide, we get 833 1/3. Something like that. Yes? No?
Yeah.
833.33. 833 1/3. What do you think?
Where did the 300 come from?
Area of the smaller figure.
Hold on.
So if we have the area of a known object, and we know that we're just enlarging it or shrinking it to make a new object, all we have to find is the corresponding lengths of one side, one feature, and we can find the area of the new object.
What is it, 300? Oh, okay.
So let's say we have,
It would work even if you had, if you go back to the drawing,
sure,
if you had, say, where it's rounded in the corner, say it was a half circle and you knew the,
maybe I just knew the radius or something there.
well, yeah, you could figure out the length of the half circle, it would work that way too.
Yep,
Okay,
any length feature.
okay.
Like here, what I plan on doing with this one is this. Let's say that I know the radius of this circle goes from 2 inches to being a 5-inch radius. So, and I know that the area of this is, oh, let's go 320 square inches, and the area of this one. So my ratio of lengths, as you said, is 2 to 5. Can't be reduced. My ratio of areas, I'm going to square that. That's going to be 4 to 25. Put the 320 up here. I cross multiply and divide, I get an area of 2,000 square inches. Yeah, I know my drawings are making it real fun to try to keep up with your notes. So how about here? Let's say we're told that this one has a perimeter of 60 inches. And this one here has a perimeter of 150 inches. And this one has an area. Oh, what do I do? Let's go 420 square inches. Let's find the area of this one. Try that in your notes. Now, does this work? Is perimeter a length? Yeah, perimeter is a length. So the ratio of lengths is just going to be the ratio of the perimeters. So go ahead and try that in your notes quick. See what you come up with.
You want us to say what it is if we can know?
Nope. So the ratio of lengths is 60 over 150, which reduces to 2 over 5, right? You square that. 2 squared is 4. 5 squared is 25. Where's the 420 go? On top. So cross multiply and divide, we get 2750 or 2525.
26.
2625. Thank you. Simple enough.
Look how that works out.
It is. We can go even further. Now, just because I'm here, we'll draw a box like this. Let's say this is 2 inches, 3 inches, and 5 inches, right?
You always have to reduce the.
You don't have to. It's just easier if you reduce the ratio. Otherwise, you get really huge numbers. I'm going to blow it up, and this is going to become 6 inches here. What's this dimension down here have to become? 9. It was 2 times 3, so it has to be 3 times 3. And of course, this is going to be 15. So we've already figured out the ratio of lengths. I can take any side, the 2 or the 6, 2 to the 6, the 3 to the 9, or whatever. It's a 1 to 3 ratio of lengths. What's the volume of this? 2 times 3 times 5 is 30 inches cubed, correct?
Okay.
What's the volume here? 810 inches cubed. 30 over 810, if I reduce that, I get a 1 over 27. Anybody want to guess what the relationship is there?
No, really, yes, you did already go over it. It's cubed.
Cubed, yes. 1 cubed is 1, 3 cubed is 27.
So, ratio of length cubed equals the volume. Right?
Yep,
That's how you put it.
yep.
That must have been something.
The ratio of lengths is 1/3.
No, the cube fire.
The cubed. 1 to the 3rd power is 1. 3 to the 3rd power is 27.
Wait, could you back up to that volume?
Sure.
1 to the 3rd is 1, 3 to the 3rd is
Cubed.
27. Okay. So for the
So
square,
ratio-
I get it.
Ratio of length cubed and then.
That's the ratio.
because the
That's it. That's the ratio of the volume.
15 has to come in to play at some point.
Well, the 15, 5 to 15 is your lengths.
Yeah.
5 to 15 is a 1/3 ratio, just like any other length.
So that's like checking the work is like actually.
Oh, so, yeah, okay.
Yeah, the 5, like the 3 to the 9 is also a 1 to 3. The 2 to the 6 is a 1 to 3. All the lengths are a 1 to 3.
I see. Yep.
Doesn't matter which one you use.
In fact, here we'll put it all together in one big piece here, just for fun, because we can, and you guys are enjoying it. Yeah, I'm enjoying it. Well, you guys don't have a choice. How's that? See, now, why don't more people figure that out? This one here, I'm going to use these symbols. The perimeter of the base of this one is 24 inches. The surface area of this one is 480. No, that's not going to work, is it? Yeah, that'll work. 480 inches squared. The volume of this one is 360 inches cubed. Find the perimeter of the base, the surface area, and the volume of that one.
did.
Yeah.
Did I?
And Nick probably used it, right?
So ratio of lengths is going to be 5 to 8. Not a whole lot we can do about that. So to find the perimeter, 5 over 8 equals 24 over what? X. Cross multiply and divide, what do we get there? 61.44 sound good? Something sounds off there. 38.4 sounds better, yes. That's the perimeter of the big piece. Nothing to square there. It's just straightforward because it's just the length. Perimeter is just a length. For the surface area, we have to do the 5 over 8, and we're going to square it to get 25 over 64. Now we'll compare that to the 480. So 64 times 480 divided by 25 is 1228.8. This was in inches. This is going to be in inches squared. Yep. For the volume, 5 over 8 to the power of 3, 5 to the third power. 5 times 5 times 5 is 125. 8 to the third power is 512. Now put the 360 up here for a volume. Cross multiply and divide, we get. What's that? 56. Very good. 1474.56 inches cubed.
Pardon me?
Cubic inches, right?
Yeah.
What do you think? Good stuff?
That wasn't too bad. Well, I got that attention from him.
You actually finally heard it. It's one of those concepts that really, there's so many things you can actually use it for if you remember that you can. Any 412 roof, you can use this type of thing for. If you know how to apply up your square number of squares of the roof and stuff like that. If you know, okay, it's a 412 roof, so now I just use the span and the length, and I can use my ratios to figure it all out. Yep. Now I want to look at something like this. Let's say 7 quarts contains 12 ounces of material. I want to know how many pounds would be required for 30 gallons.
How many pounds required for what?
30 gallons of material. 7 quarts contains 12 ounces. 30 gallons would contain how many pounds?
Okay.
There's 2 ways we can go about this. We can convert either before or after. This one, I'm going to prefer to convert after because we're going to bigger units. So we'll take the 27 ounces here. The 30 gallons has to be converted into quarts. To be a proper proportion, the units here have to be the same as the units here. Remember, read those relationships? So this is quarts per ounces. This is going to have to be quarts here. This is going to have to be ounces. Yes, there are 4 quarts per gallon. So 30 gallons is going to become 120 quarts. So 120, 12, so we're going to cross multiply and divide. You got it. 12 times 120 is 1,440. Divided by 7 is 7142857,143 approximately.
Yeah. I feel that I'm a little fucking
205.71, we'll call it. That's ounces though, but we need it back into pounds, so we're going to have to take that divided by 16, right, to make it pounds, which is 12.8571428.6 approximately.
Yeah.
Okay. Or
Usually
12 and
you
6.
try to go even with that,
Just to make my point, yeah.
Just to prove your point.
So, you have that worksheet from yesterday that I gave you, the one you just got now, Nick. I want to make sure you go through and finish that up, because I want to talk about that a little bit on Tuesday when everybody comes in. In the packet, you guys have a packet that, I believe you guys have a packet where we did the measurement calculations. That one you've got there, Nick, hold it up. That one? Yep, hold it up so everybody else can see it.
The one we just did the first.
Yep, we just did the first page on, yep. On the very back page of that, there's like 6 questions on the bottom. How many questions are on the bottom there, those proportions? Yeah, there are 6 of them. They look similar to this, where they're proportions with a missing number, but the units are different from one to the other. So I want you to see if you can figure out how to convert the units to make it so you can find the answer they're looking for. So it's a ratio, it's a proportion, you got to cross multiply and divide, but you also have to do unit conversions. Did you see which one they are, Mike?
Yep, the ones on the bottom.
The last 6 on bottom. And then the last thing I'm going to give you is I'm going to give you a quiz to take home over the weekend for Tuesday.